Hey everyone, welcome back to Silicon to Software. I'm your host Imran, and today we're talking humanoid robots. You've seen the videos: Tesla's Optimus, Figure AI, Boston Dynamics, smooth movements, clean floors, perfect lighting. Here's the problem. Those demos are choreographed. No forklifts, no coolant mist, no forgotten pallet jack about to clip the robot's leg. Real factories are a different planet, and nobody's demo video shows what that planet does to a robot over 18 months. So let's talk about the real bottleneck. Spoiler, it's not the AI. The brains are actually in great shape. Vision language models, motion planning, whole body coordination, that part's basically solved. The body is where things fall apart, literally. Constant vibration from conveyors and forklifts, thermal swings between a loading dock and a paint oven, metal shavings and hydraulic fluid working into every seam. That's daily life on a factory floor, and it's brutal on hardware. Let's go gap by gap. Gap 1. Actuators, the motors that move a robot's limbs. Hydraulic actuators are strong, but they leak, and they need heavy maintenance. That's actually why Boston Dynamics moved Atlas to all electric. Electric actuators are cleaner, but they can't match hydraulic power at the same weight. And here's the kicker. Nobody's published real failure rate data for actuators under actual production loads. That's the first number every buyer wants. Still missing. Gap 2. Hands. This is the hard one. Human hands have 27 bones and constant sensory feedback. Robotic hands are nowhere close. Figure's newest hand has 16 degrees of freedom. Impressive on paper. But research labs are still celebrating hands that survive just 20 hours of continuous use before wearing out. 20 hours. As a milestone. Factories need years. Gap 3. Battery life. A human does an 8 to 10 hour shift. Most humanoid robots today are landing closer to 5 hours per charge. Tesla says Optimus is good for a full day, but that's Tesla's word, not an independent verified number, and when a battery voltage sags, robot torque drops with it. That's a safety issue, not just an inconvenience. Gap 4. Sealing. Keeping dust and moisture out sounds simple, until you need that seal to survive a shoulder joint rotating through multiple axes non-stop for 40,000 hours. Sealing a static box is solved. Sealing a moving joint at that scale is not. Gaps 5 and 6. Safety standards. Working next to humans means real regulatory hurdles. ISO 10218, ISO 15066. Good news, a humanoid-specific standard is finally in draft. Bad news, it's not enforceable yet. And Gap 7, the one nobody talks about, cybersecurity. These robots are Linux computers with legs wired into the same factory networks that have been a security weak spot for years. We already saw a real vulnerability disclosed this year in an industrial robot controller. A critical flaw letting an attacker run commands remotely. A hacked robot isn't just broken. It's a doorway into your whole network. So where does that leave us in 2026? Optimus is running limited internal tests at Tesla's own factories. Figure is testing with BMW. Atlas is testing with Hyundai. All real. All still pilots. None of them have published hard reliability numbers. For comparison, standard fixed industrial robot arms run 80 to 100,000 hours between failures. Humanoids aren't there. Not yet. Here's my bottom line. The AI raced ahead. The hardware didn't, and the company that wins this race won't be the one with the best demo reel. It'll be the one that solves actuator durability, hand longevity, and OT security first. Watch the specs, not the videos. That's it for this episode. For the full breakdown, sources, standards, and the data behind every claim, head over to silicontosoftware.com. Thanks for listening, and I'll catch you next time.